Alright team, welcome to the playbook for streamlining your data operations with Apache Kafka. For those joining us, you already know how critical a smooth, uninterrupted data flow is to your systems. Now let's think of your data operations like a vast, complex factory floor. Every machine, every worker, every conveyor belt must be perfectly coordinated to ensure smooth material flow, efficient production lines, and reliable delivery of products. Today, we're unpacking Kafka, understanding its core architecture from a team lead's perspective. Less about the intricate code, more about the operational levers you'll need to pull. At its heart, Kafka is a distributed streaming platform. You might be thinking, isn't this just another message queue? And while it does queue messages, that's like saying a modern logistics hub just stores boxes. Kafka is designed for high throughput, fault-tolerant, real-time data feeds. It's the central nervous system, the backbone of your factory, ensuring raw materials, your data, flow continuously without bottlenecks, ready for processing at any stage. It's about establishing that reliable, persistent pipeline for every piece of information moving through your systems, enabling complex data operations to run like a well-oiled machine. To truly grasp its operational impact, let's look at the core components. First, we have brokers. These are your individual Kafka servers, like the various workshops or production lines on our factory floor. They store the data. Then come topics, which are essentially categories or types of data streams.
Think of them as dedicated conveyor belts for specific product lines, like customer orders or payment transactions. Within each topic, data is further divided into partitions. These are ordered, immutable sequences of records, allowing for parallel processing and scaling throughput. Imagine separate lanes on that conveyor belt, ensuring ordered delivery even during peak demand. And critically for team leads, each partition has replicas across different brokers, ensuring data durability and fault tolerance. In real systems, this shows up when you face a broker failure. If you've configured your replication factor correctly, your data flow simply shifts to a replica, preventing downtime and potential data loss, a major concern for any production system. Now, how does data get onto and off these conveyor belts? That's where producers and consumers come in. Producers are your data sources, applications writing data to topics, much like machines placing items onto a conveyor belt. Consumers are applications reading data from topics, processing it, much like workers taking items off a belt for the next stage of assembly. Consumers work in consumer groups to allow for parallel processing of a topic's partitions, efficiently scaling out your data consumption without duplicating effort. And orchestrating all of this, ensuring our factory runs smoothly, is the controller, historically Zookeeper, now increasingly Apache Craft. It's the central command, maintaining crucial metadata about brokers, topics, and partitions, ensuring consistent coordination across the entire distributed system. For team leads, understanding this control plane is absolutely key for proactive cluster health monitoring and swift troubleshooting. So Kafka isn't just a simple tool, it's a foundational architecture that transforms how your data moves and scales. Understanding these core pieces, brokers, topics, partitions, replicas, producers, consumers, and the controller, is essential for any team lead looking to build truly resilient and high-performing data operations. Next up, we'll dive into why Kafka's operational advantages truly outshine traditional messaging systems.
Alright team leads, let's get down to brass tacks. Why Kafka over traditional messaging systems, especially when you're dealing with serious data volume? You might be thinking, we have a message queue, it works. What's the real advantage here beyond just buzzwords?
Well, picture our complex factory floor again.
Traditional messaging is like having a few large, centralized conveyor belts. They can move a lot of materials, sure, but if one jams or breaks, everything grinds to a halt. And if you suddenly need to double your production, adding another massive belt is expensive, slow, and disruptive. Kafka, on the other hand, is designed from the ground up for massive parallel processing. It's more like an infinitely extensible grid of smaller, interconnected conveyor lines, each handling a specific material flow. This distributed architecture means truly scalable throughput. You can easily add more belts or Kafka brokers and partitions
horizontally, without significant downtime or complex reconfigurations.
This elasticity is crucial for modern operations, where data spikes are the norm, not the exception. We're talking about handling millions of events per second, consistently, which, frankly, most traditional queues just choke on, becoming operational bottlenecks and a constant headache for your team to manage. Beyond raw horsepower, Kafka's reliability and durability are game changers for operational teams. In real systems, this shows up when you can't afford to lose a single transaction, a critical log event, or a real-time metric. I've seen teams struggle with traditional queues that, during a system restart or a network hiccup, would simply drop messages or take ages to recover, leading to data inconsistencies and frantic debugging sessions. Kafka's secret here is its append-only, immutable commit log with built-in replication across multiple brokers. It's like having a tamper-proof ledger for every single piece of material on our factory floor, with multiple copies stored in different locations. Even if an entire conveyor belt section goes down, a replica instantly takes over, and no material is lost. This isn't just about speed, it's about trust. It means your data operations are production-ready, durable, and resilient to failures that would cripple older systems. Your stakeholders won't be calling at 3 a.m. asking where their data went. Finally, for us as team leads, Kafka's maintainability and its mature ecosystem drastically reduce operational overhead. Unlike some newer, less battle-tested distributed systems that might promise marginal performance gains but come with a steep learning curve and immature tooling, Kafka has a robust, enterprise-grade tooling landscape. This means easier monitoring, simpler scaling, and predictable behavior. It's a system built by and for large-scale operations, meaning fewer surprises and a more stable environment for your engineers. Its consistent API and clear operational patterns allow your team to build resilient data pipelines with less specialized knowledge than you might think, freeing them up for more impactful work than constant firefighting. This isn't just about buying a tool. It's about investing in a platform that simplifies your operational challenges at scale. Next, we'll dive into the specific operational headaches Kafka solves and how it impacts your team's KPIs. Okay, so we've established Kafka's architectural advantages. But where does the rubber truly meet the road for your team? Let's talk about the specific operational headaches it solves and how it directly impacts your key performance indicators. One of the most persistent frustrations for any team lead is data loss or inconsistency. You know the drill. A critical message disappears, an order status gets out of sync, or a payment notification never arrives. It's like a crucial component vanishing from your factory floor, bringing an entire assembly line to a halt. This isn't just an inconvenience. It means regulatory fines, lost revenue, and hours, sometimes days, of engineering time spent on forensics, completely draining team morale and productivity. Kafka fundamentally addresses this with its durable, replicated log. Every message written to Kafka is persisted to disk and replicated across multiple brokers. This means even if a server fails, your data isn't lost. You're building a system where critical messages are guaranteed to be delivered and processed, reducing those agonizing data loss incidents to near zero. What does that mean for your KPIs? A significant boost in system uptime and rock-solid data integrity metrics, giving you and your stakeholders confidence that the factory floor is always running, reliably, without unexpected stoppages. Beyond durability, another common struggle is performance bottlenecks. Think about those peak times, Black Friday sales, month-end reporting, or sudden traffic surges. Your traditional messaging queues start choking, messages pile up, and suddenly, your real-time dashboard is running 10 minutes behind, or user actions aren't being processed fast enough. The assembly line is there, but the raw materials just aren't flowing efficiently enough to meet demand. If this feels familiar, you're definitely not alone. I've seen teams spend countless hours tuning database queues or horizontally scaling individual microservices only to hit another bottleneck upstream. With Kafka, its inherent design for high-throughput, low-latency data ingestion changes the game entirely. Its decoupled architecture allows producers to firehose data in and consumers to pull it out at their own pace, massively increasing your system's overall throughput capacity. This direct improvement means your data operations can keep up with demand, virtually eliminating message backlogs and dramatically improving data freshness. We're talking about measurable reductions in latency and a dramatic increase in message processing throughput, moving those materials through the factory at unprecedented speed. Finally, let's talk about the operational nightmare of debugging distributed systems. When something goes wrong across a dozen microservices, trying to trace a single transaction's journey can feel like searching for a needle in a haystack. Or, sticking with our analogy, trying to find a faulty part in a sprawling factory without any consistent tracking system. It's a huge drain on development and operations resources, directly impacting your mean time to resolution, or MTTR. Kafka's log-centric model simplifies this immensely. Because messages are stored in a strict ordered sequence and retained for configurable periods, you gain an immutable audit trail. This persistent history allows you to replay events, understand the exact sequence of operations, and pinpoint failures with unprecedented clarity. It essentially gives you a detailed, perfectly ordered logbook for every single item moving through your factory, making fault diagnoses a structured, repeatable process. The operational implications are huge. You'll see a significant drop in mean time to resolution, MTTR, freeing up your engineers for innovation, not just firefighting. This reduction in debugging complexity, combined with Kafka's robust tooling ecosystem, makes day-to-day operations far more manageable. But what exactly are these tools, and how do you get started with them? That's what we'll dive into next. After we've tackled those operational headaches, the next crucial step for any team lead is equipping your team with the right gear. Think of it like a sophisticated factory floor. You wouldn't just throw raw materials at your workers and expect perfect products. You need the machinery, the assembly lines, the very infrastructure to make it all flow. For Kafka, this means having solid deployment and orchestration tools. These aren't just technical details. They are strategic decisions that impact your team's velocity and the system's reliability from day one. When you're streamlining data operations, the foundation for that efficiency begins with how effortlessly you can spin up, configure, and scale your Kafka clusters. Without proper automation here, you're constantly battling manual toil and human error, undermining all your other efforts. Once your Kafka clusters are running, the factory floor is operational. But are your production lines humming smoothly? Are materials flowing without bottlenecks? That's where monitoring and observability tools become your eyes and ears. I've seen teams get caught in this trap. They deploy Kafka, assume it's a black box, and then scramble when issues arise because they lack visibility. You might be thinking, how do I know if my data is durable, if performance is truly optimized, or if the operational overhead is actually justified? This is critical, especially when evaluating new distributed systems against established ones like Kafka. Robust monitoring isn't just about pretty dashboards. It's about understanding latency, throughput, consumer lag, and disk usage across every broker and topic. It's about catching small hiccups before they become catastrophic failures, ensuring your data pipelines are not just running, but truly thriving with the promised efficiency. Beyond just seeing what's happening, team leads need tools that enable proactive management and simplify day-to-day operations. Imagine having a central control panel for your entire factory floor. One place where you can manage product routing, adjust production quotas, and even quickly reroute materials if a line goes down. That's the role of management UIs and operational dashboards for Kafka. These aren't just nice-to-haves. They are essential for abstracting away complexity, giving your operations team the power to manage Kafka topics, consumer groups, and security without deep diving into command line interfaces for every single task. It frees up your senior engineers for more complex architectural work, allowing your broader team to confidently maintain the smooth flow of your data factory. This kind of mature tooling ecosystem is what truly justifies Kafka's adoption at scale, proving its operational simplicity over alternatives. Looking ahead, this seamless management directly informs how we integrate Kafka into our existing systems. Alright team, let's talk about bringing Kafka into our existing architecture. It's not just about flipping a switch. It's a strategic shift. Think of it like coordinating a complex factory floor. You wouldn't overhaul the entire production line overnight without understanding every existing conveyor belt and assembly station, would you? Our first step is a smart, phased approach, starting with a thorough assessment of our current data flows. This means understanding where data lives now, how it moves, and frankly, where the bottlenecks and friction points are. We then identify those high-impact pilot projects, the ones where Kafka can make a tangible difference quickly, proving its value without disrupting critical operations. This initial discovery phase is crucial for defining clear, measurable success metrics from the start, and building a core group of Kafka champions within the team. They'll be our early adopters, our internal advocates, and the ones who truly understand the why behind this transformation. Once we have our assessment, the real work of implementation begins, but it doesn't have to be a big bang. We embrace agile deployment sprints for Kafka, integrating it incrementally. You might be thinking, this sounds like more operational overhead. And you'd be right, if not managed carefully. That's why prioritizing rock-solid configurations for data durability isn't optional. It's fundamental. We're talking about configurations that ensure data integrity, even during leader failures, directly addressing those nagging concerns about committed data loss. I've seen teams jump straight into deployment without deeply considering these aspects, only to face painful data recovery scenarios later. Instead, we focus on continuous monitoring and performance tuning, building out a robust operational playbook. We're not just deploying, we're refining, learning, and documenting every best practice along the way, turning potential headaches into predictable, efficient processes. But technology is only half the battle. The other half is our people. Ensuring team readiness and cultural alignment is paramount. This means investing heavily in Kafka training and certifications, empowering our engineers with the skills they need to not just use Kafka, but to master it. We need to foster a data-driven mindset across the team, shifting from reactive problem-solving to proactive, stream-oriented thinking. By creating shared ownership models, where everyone feels responsible for the health and performance of our data pipelines, we build a more resilient and collaborative environment. And don't underestimate the power of celebrating early wins and learnings.
These small victories reinforce confidence, build momentum, and smooth the cultural transitions. Because ultimately, successful Kafka implementation isn't just about deploying a new tool. It's about evolving how our entire team approaches data operations, making us more agile and responsive. With these foundations in place, we'll be ready to truly leverage Kafka's unique strengths. Next, we'll dive into Kafka's key operational differentiators, the factors that truly set it apart for reliability and scale.
Alright, as a team lead, you're not just looking for a new tool. You're looking for a solution that brings rock-solid reliability and performance without creating more headaches. You need something that's genuinely production-ready. That's where Kafka truly differentiates itself. Think back to our factory floor analogy. If Kafka is the conveyor belt system, these differentiators are what make it incredibly resilient and efficient, ensuring smooth material flow and reliable delivery, even under immense pressure. We're talking about three critical pillars here: uncompromising data durability, built-in fault tolerance, and truly limitless horizontal scalability. First, let's talk data durability. A concern I know many of you have, especially when considering new systems. Kafka's foundational design is a commit log. Every message is written to disk, sequentially, before being acknowledged. This isn't some flaky in-memory cache. It's a robust append-only log, replicated across multiple brokers.
You might be thinking, but what about data loss during a crash?
Or what about FSYNC? Kafka addresses this head-on. With configurable replication factors, your data is synchronously copied to multiple nodes. If a leader fails, a follower takes over, often without any data loss. This log-based persistence model, combined with proper configuration, gives Kafka enterprise-grade data guarantees. Unlike systems where a leader failure could mean losing committed data, it's about ensuring your raw materials, your data, are always where they need to be, safe and sound.
Second, Kafka offers built-in fault tolerance.
This isn't an afterthought. It's fundamental. Kafka clusters are designed to operate continuously, even if individual machines fail. Brokers constantly monitor each other. If one goes down, replicas step in seamlessly. The system automatically rebalances, minimizing disruption. I've seen teams leverage this during critical infrastructure upgrades or unexpected hardware failures, where in older messaging systems, even a minor hiccup would cascade into hours of downtime. This automatic failover capability means your production lines keep running. Your data pipelines don't just halt and demand manual intervention, they recover. It drastically reduces your mean time to recovery, or MTTR. Because the system heals itself, it ensures that crucial components of your factory floor continue to operate, delivering products without interruption. And finally, horizontal scalability. This is where Kafka truly shines for growth and efficiency. Unlike many traditional message queues that hit bottlenecks with high throughput, Kafka is designed to scale out, not just up. You add more brokers, you add more partitions, and your capacity grows linearly. This partitioning strategy, combined with consumer groups, allows you to distribute processing across hundreds or even thousands of consumers, all reading from the same topic in parallel. It means that as your business grows, as your data volume explodes, Kafka scales with you effortlessly, without requiring a complete architectural overhaul. It's about expanding your factory floor, adding more production lines, and ensuring your material flow never chokes, no matter the scale. These differentiators are what make Kafka a cornerstone for modern, data-intensive operations. They translate directly into higher system uptime, lower operational overhead from incident response, and the flexibility to grow your data infrastructure without fear. Next, let's look at some real-world operational use cases where these strengths are put into practice, driving measurable efficiency.
Alright, team leads. We've established Kafka's core operational strengths like durability and scalability. But where does this power truly manifest on the ground? How does it translate into tangible, measurable wins for your daily operations? First, let's talk about real-time log aggregation and analysis. If you've ever spent hours sifting through distributed logs, trying to pinpoint the root cause of an issue after the fact, you know the pain. Kafka centralizes these logs from countless services into a single, high-throughput stream. This isn't just about collecting data. It's about making it instantly actionable. Think back to our factory floor. If a machine on one of your critical production lines starts sputtering, you need to know instantly, not hours later, after someone manually checks a logbook. With Kafka, you can push those logs to analytics tools in real time, enabling proactive alerts and drastically reducing your mean time to resolution, or MTTR, by as much as 40%. You're literally detecting issues before they impact customers. Next, consider high-throughput, real-time metrics and monitoring. Go. You might be thinking, my current monitoring system gives me graphs. But often, those dashboards are updated in lagging batches, or rely on heavy polling that itself adds operational overhead. Kafka transforms this by enabling truly live streaming of performance metrics from every corner of your infrastructure. This means immediate visibility into system health, allowing for proactive intervention and even predictive analysis. I've seen teams leverage Kafka to transform their monitoring from reactive firefighting to proactive management. Instead of waiting for a system outage to be reported by users, they're now catching anomalies, like a sudden spike in latency or error rates, as they happen, leading to significantly improved system uptime, often by 15% or more, simply by having the data when it actually matters. Finally, Kafka excels at building resilient data pipelines. How many times have you dealt with fragile point-to-point integrations that buckle under load or lose critical messages during a transient network glitch? Kafka provides a durable, scalable backbone for these pipelines, decoupling producers from consumers and guaranteeing message delivery even during system failures. This directly addresses those nagging concerns about data durability and production readiness that often come up in discussions. Kafka becomes the robust, intelligent conveyor belt system for your factory floor, ensuring every component gets the exact materials it needs, precisely when it needs them, without dropping a single part along the way. The outcome? Data loss incidents can plummet by 99% or more, ensuring the integrity of your most critical information flows. Implementing these solutions isn't without its considerations, though. While Kafka offers incredible power, mastering it requires navigating its unique landscape. Next up, we'll dive into some common pitfalls and how to mitigate them effectively. Alright, team leads. We've covered a lot of ground on Kafka's power and potential, but now it's crucial we talk about the tripwires. The common pitfalls and misconceptions that can derail even the best intentions. The first, and perhaps most insidious, misconception is underestimating Kafka's operational complexity. You might be thinking, it's just a messaging queue, right? How hard can it be to run? Well, it's far more than that. It's a distributed system, and treating it like a simple message broker often leads to poor design choices, insufficient monitoring, and eventually, unexpected outages. Running Kafka effectively is like coordinating a complex factory floor. It's not just about pushing materials from station A to B. It's about ensuring every conveyor belt is properly maintained, every sensor is online, and the entire flow is resilient to individual machine failures. Ignoring this foundational complexity is a recipe for operational headaches down the line. Another critical area where teams often stumble is data durability and the risk of data loss. I've seen teams run with default Kafka configurations in production, only to face data loss during a broker restart because they overlooked critical settings like AX or replication.factor. They assumed their committed data was safe, only to find out the hard way that a leader failure could compromise integrity. It's a pragmatic concern, especially when budget and timelines push for shortcuts. Durability isn't just about disk writes, it's about the entire transaction model. Not properly configuring your producers with AX equals all and setting minimum in-sync. Replicas can mean your data is acknowledged as written, but isn't actually durable across enough brokers to survive a failure. This isn't just a technical nuance, it's a business risk. Finally, let's address the operational overhead and the challenge of tooling maturity.
Implementing any distributed system introduces an operational burden. While Kafka has an incredibly mature ecosystem, I hear concerns about the operational overhead of new distributed systems. For Kafka, the pitfall is often underestimating the need for dedicated operational expertise, robust monitoring, and automation. Without a mature tooling strategy for everything from schema management to access control, your data pipelines become fragile and difficult to debug. This isn't just about performance. It's about maintainability and the cost of ownership, especially when scaling. So how do we avoid these issues, ensuring we're ready for what's next? Next up, we'll put your understanding of these operational fundamentals to the test with a quick knowledge check. We've navigated the complex factory floor of data operations, understanding Kafka's role in ensuring smooth material flow and reliable delivery. Now, let's put that knowledge to the test with a quick operational fundamentals check. You might be considering how to ensure the systems you build are truly production ready, especially when concerns about data durability often pop up, or how to justify Kafka against alternatives without sufficient performance gains or operational overhead. So for our question, what is the most critical configuration pairing to ensure robust data durability in a Kafka production environment, preventing data loss during broker failures? Take a moment to think it over. Alright, the clock's ticking. The correct answer is option B, setting producer AX equals all and broker minimum in sync.replicas. Here's why. In our factory analogy, AX equals all is like having every material handler confirm receipt of a critical component at the next station before the initial handler releases their grip. And minimum in sync.replicas ensures there are always enough backup, stations, or replicated copies that have also confirmed receipt. Without both, you're risking losing committed data, a pain point we often hear about from pragmatic Reddit discussions. For instance, in real systems, this shows up when you're dealing with financial transaction logs or critical event streams, where even a single message loss is unacceptable. It's about finding that balance between performance and the absolute guarantee of not losing committed data, preventing those significant operational headaches down the line. It avoids scenarios where, during a leader failure, committed data might disappear because it wasn't sufficiently replicated or acknowledged. Next, we'll shift our focus to charting your personal Kafka journey, planning for operational excellence within your own team. We've journeyed through Kafka's core concepts, explored its operational advantages, and even looked at common pitfalls for team leads. We've thought about it like meticulously coordinating a complex factory floor, ensuring every part moves smoothly from raw materials to a finished, reliable product. Now, the crucial question isn't just about understanding Kafka, but how it applies to your unique operational landscape. You might be thinking, this all sounds great, but how do I actually start translating this into tangible wins for my team and our specific data flow bottlenecks? So I want to hear from you. Considering your current systems and our factory floor analogy, what is the single most pressing operational challenge your team faces today that you believe Kafka could fundamentally transform or optimize? What's that one bottleneck that's really slowing down your production line or impacting product delivery? Sharing your insights not only helps you formulate your own strategy, but also enriches this community's collective knowledge. We read every comment. Thank you for joining us on this deep dive into Kafka for operational excellence. If this discussion resonated with you, please hit the like button. Drop your most pressing operational challenge in the comments below. I genuinely want to know. Subscribe to Make Even Developer for more expert insights and hit that bell icon to stay updated. And for a comprehensive deep dive, make sure to grab the full Kafka playbook for efficiency, linked in the description below.